Section 8.5, Congruent Polygons. Our goal for this lesson is to identify congruent angles and sides in polygons. We are focused mostly on triangles in this lesson, actually completely on triangles. Our vocabulary. We have congruent segments. These are segments with equal lengths. Congruent angles, you can guess, these are angles with equal measures. And then corresponding parts. These are segments or angles that are in the same positions on congruent figures. And we're going to look at two congruent figures right now. We have two triangles. I'm calling the one on the left triangle ABC, and the one on the right triangle FED. And the reason why triangle FED is not being named alphabetical is for this reason. These two triangles are congruent. So we enter our little congruent symbol. Remember, it's equal sign with our little squiggly up top. And notice the order of how the angles are named in our triangle identification. We start with A and we start with F, B and E, C and D. Now if we look at our triangles, we notice that angle A has that same one little arc as angle F. This tells us that the angles are congruent, and we indicate it like this. Now we see that angle B and angle E are both right angles, which means they are congruent as well. Which then leaves us with angle C and angle D. The two arcs by these angles tell us those are also congruent. We also have segments in these congruent triangles that are congruent, and we tell those by the tick marks. This side right here, segment AB, has that one little tick, just like segment EF or FE has that one little tick. So we say those segments are congruent, and we write it as so. Now, technically it doesn't matter which order you list your letters for the segments. AB is the same as BA, FE is the same as EF. But if we look at the triangle notation, and since AB is in that order there and FE is that order there, I chose to keep it like that. But I will not mark it wrong if you do it the other way. So see if you can go ahead and name the other corresponding parts. And I'm going to pause the video on my end and write them down. You do the same. Hopefully this is what you found for the other congruent segments. Segment AC is congruent to segment FD. And segment BC is congruent to segment ED. We have three types of congruent triangles. The word congruent is very important. You'll see why momentarily. Our first type we call side, 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 or SSS. This is when we have two triangles with three congruent sides. Look for those congruent sides by the tick marks. Congruent, congruent, and congruent. So we're good there. Side, side, side. Next, we have what's called side angle side, SAS for short. This is if two sides and the angle between the congruent sides is congruent as well. So we look here. This side is congruent with that side, this angle with this angle, this side with this side. Side, angle, side. Our third type of congruent triangle is angle side angle, or ASA. This is if two angles and the side between them are congruent. So kind of the opposite of side angle side. And we have it here. Angle, side, angle. Angle, side, angle. We also have a theory or a definition for similar triangles. Okay, remember, congruent versus similar are a little bit different. We have what is called the AA similarity postulate. And this states, if two angles of triangles are congruent, then the triangles themselves are similar. Okay, please do not mix up congruent and similar. Similar. See, we can have triangles that have all the angles the same, but the side lengths could be different. So we see here, we have these two angles are congruent with these two angles. Therefore, the triangles are similar. They could be congruent, but they are definitely similar. So, for our final slide, we're looking at two congruent triangles. Now, how do we know that these triangles are congruent? Well, based on the drawing that's given, we see we have the sides here are congruent, the angles here are congruent, and the sides here are congruent. So we have a side, angle, side congruence. Since we know these triangles are congruent based on side, angle, side, we can go ahead and then solve the following equation. If side AB equals 2x plus 6 and side DE equals 7x minus 19, what is the length of each side? Now, since we know these sides are congruent, that tells us to set up these two expressions equal to each other. From here, it's just equation solving. So go ahead and solve the equation. Pause the video. Now, in case you couldn't tell, I'm doing this lesson from home, so I'm trying to write all the notes using the mouse pad, hence the really sloppy handwriting, worse than usual. But we do our equation steps. I like keeping things positive if possible. So I took 2x off of the left side to get down here, and then I added 19 to both sides, so I was able to stay positive. 25 equals 5x. Divide both sides by 5. We get 5 equal to x. Now we're trying to find the length of each side, so this kind of checks our equation for us. So plug in 5 for x. If we plug in 5 here, 2 times 5 is 10, plus 6 is 16. Plug in 5 here, 7 times 5 is 35, minus 19 is 16. The two sides are congruent. This concludes your lesson on congruent polygons.